Hello, everyone. My name is Brandon Pierce. I'm a principal engineer at Hypergiant, a Solid company. We create AI-enabled applications for the Department of Defense and infrastructure, other kind of initiatives. I wanted to talk today about how and why my team and I created a custom React render for deck.gl. So why make a React render, right? It's a package does already exist for deck.gl for React. Our team believed that there were certain advantages worth pursuing. Notably, one, no hacks or workarounds needed to integrate deck.gl. I like to describe this as bridging versus integration. So instead of a series of tricks or bridges to make things work in a library or framework environment, we are instead getting low-level access to both. Generally, a library will have its own sort of nuances and quirks that are worth optimizing towards. And using a custom renderer allows you to tie directly into the deck.gl or the React reconciler and have kind of maximized control over both of those things. Number two is unlocking full power of React's composition model. We'll go over composition a bit more in a later slide, but the kind of key takeaway here is that we don't want to restrict developers in any way with how they kind of craft their React applications. Number three, help developers prevent performance foot guns. This ties a bit into number five, but an interesting side effect of using a custom renderer and working with it is that the intuition for what would make good React performance also makes for really good deck.gl performance. So they kind of go hand in hand. Number four, integration with some of the incoming features for the React landscape, so notably React Server Components and React Compiler. You can adopt these features for little to no overhead. It's basically just some additional configuration updates. And they unlock some really, really cool techniques that we'll show off in a later slide as well. And then number five, teams can just think in React. We find this concept pretty powerful. So it can be a bit daunting for a large team, especially to kind of learn and all adopt a library from scratch. Using a custom React render, the team is sort of getting the look and feel of React. And they also kind of have some baseline intuition then, because of that, for how that will work, essentially the deterministic output of that implementation. They don't necessarily have to know all of the nitty-gritty details of the underlying library per se. So the underlying or the overhead for training could be much less in that scenario. So preventing foot guns or the oopsie-doopsie principle. Before I go into detail of what a React render is, I did kind of want to explain more of the why as far as why we went down this path. So the application that my team works on has a very, very large number of bespoke layers, each with their own particular nuances. They have very specific interaction behaviors. They have a bunch of additional side effects to each of them. With the existing deck.gl React package, our team was kind of constantly trying to chase composability patterns. So in this example here, we were able to maintain pretty good portability by exposing both React components and deck.gl layers via hook. What's nice is that you could port this hook around wherever you want, and everything is sort of self-contained, and you're isolating behavior and you're exposing your artifacts from a single spot. It's really, really convenient. However, because the hooks have to exist at the topmost React component, so we can feed those layers to the deck.gl component, that means any re-render that occurred in those hooks actually cause a full re-render of the entire component tree due to the way that React works. And this is not a massive deal for trivial applications, but as you kind of grow in complexity and scale, this can start to introduce some performance issues to your application. We're really just trying to make sure that we can always reduce the surface area for bugs and performance issues. It's really fun when a developer adds a RAF loop to React state and then suddenly your FPS goes down to 3. Things like that can happen, right? So we're trying to reduce that situation. So React renders, what are they? If you ever worked with React before, the code on the right should look kind of familiar. You set up a root that points to a DOM node, call a render function, pass in a component, and then kind of React takes over from there. You'll start to work with things like DOM nodes like divs or spans or images. You'll work with things like props and states for the actual components. Implement side effects with things like hooks, use effect and such, or optimize callbacks with use callback, etc. You work with things like keys and refs and context and other type of primitives like React.lazy React.memo, error boundary, and suspense. So what's interesting is that actually all of these features are shared across all React renders implementations, except for the first one highlighted in blue there. That's what's known as a host component, which is produced in a host environment or host context. And a custom renderer is defined by its host configuration host components. So the host configuration is what manages the internal React fiber nodes, which are kind of just like descriptive objects that tell React how to do its magic underneath the hood. The host configuration has notions of what are sometimes referred to as commands. These are pretty self-explanatory for the most part. You have usual suspects like append child, remove child, insert, all that kind of fun stuff. There's also sort of sibling use cases like insert before, and then more lifecycle phase type commands like update, commit, update, reset after commit, etc. The list of commands is actually pretty large, and it will change depending on the type of mode that you're in. And unfortunately, almost all of it's undocumented. So enough trial and error, you can kind of figure out what does what. So shout out to console.log for that. And what's really interesting too is that oftentimes this is one of the areas that the React team will make a breaking change in, since they kind of label this a little bit as unstable to a degree. And since you're dealing with the actual root fiber nodes, you have to be a little bit careful about how you interact with those because they can change those. But the key takeaway here is that instead of trying to work around the various quirks via methods like useEffect and like tying into maybe different callbacks, or even like adding additional methods or properties or callbacks to deck.gl itself to accommodate those type of things, we can instead tie directly into these commands and have very low level control. So what does it look like in code? So layer JSX looks a lot like React DOM. Layers are defined like DOM nodes in camel case. You have support for React primitives like children, fragment, and suspense. Props, keys, refs, etc. They all work like they do in React DOM. So like in this example here, we're in two different map views. Maybe one's like a mini map, and then we're adding a few sibling layers inside of there. Hooks are also supported. So in this example, we might want to tie in a render sublayer callback or a tile layer where we're maybe conditionally changing the type of thing that we're rendering based on some state or user-driven state or whatever it may end up being. And a further look at React hooks, a little bit more of a realistic example. In this scenario, we might want to say visualize a clicked object as an icon and have the rest of the data as a scatter plot. We're utilizing, in this case, a use callback to optimize the interaction callback and the function accessor. We're using use memo to convert the clicked object into a collection for the deck.gl data prop, using use state to manage the actual click info itself, use effect to log the output, and a custom hook from Tanstack query to fetch the data. All this can be shared and ported and make reusable and used in other spots, right? So we're driving home the notion of just thinking in React here, where the same exact techniques and strategies that you would normally use in React apply here as well. And we'll actually see in a later slide how the React compiler can clean this up and make it much better. Extending custom layers are absolutely supported. Any custom layer can be made aware to the renderer with the extend method. By default, all of the deck.gl layers are extended, so you can use those straight away in your JSX. And it allows you to kind of organize your files however you see fit. The composition, which kind of is a broad term here, but really what we mean by this is the idea that I can take small and encapsulated components and combine them together in various ways, declaratively to create complex component interactions and great user experiences. We are effectively trying to achieve a few principles all at once here. Single responsibility, reusability and modularity, it's simple, stupid, and separation of concerns. And these principles are really mandatory for maintaining very complex React applications at scale. And if your library or package cannot accommodate those, it means that you're essentially building towards tech debt. In the code example here, for instance, we have the kind of root component my layer to returning a layer A. Layer A in turn renders out a scatterplot layer and then also renders another component, layer B, and so on and so forth. So you can kind of nest these as freely as you want. And the tree order in React actually reflects the exact layer order as well for deck.gl. So it's really intuitive and makes a lot of sense. React children are also supported and encouraged. So instead of rendering a component directly in another, we could swap to use the children prop and compose it together however we please, like in the updated my layer example here. There's actually some additional performance benefits with this as well, but again, it's just giving more freedom to the developers to compose these in whatever means makes sense. We may have abstractions around our data fetching that we wish to use both in deck.gl and more traditional React components. So a common example of this being that you want to render data on a map and you want to take that same exact data and render it in tabular form in like a sidebar list view or something, right? You're fully free to encapsulate the data fetching logic and state into a single hook, and then use that in any of these rendering contexts. And this is the same concept for state or effects or things like shared context, etc. Again, always just thinking in React. And kind of remembering that example I showed earlier with how we were encapsulating the layers, you can see that with the React render approach, we're kind of free to decouple these components out. We can split the data fetching logic into its own shareable hook. We can prevent excessive rendering because we don't need to actually have those hooks any longer at the root of the component tree, and all that kind of great benefits of doing this. So you kind of see here at the bottom, hopefully it's visible, we have the layer actually in the deck.gl component, and then the React DOM my list layer is separate, and then they're both kind of sharing things like get data, which is a generic data fetching utility in this case, and the list goes on. So other things like React Memo are also supported, and they kind of work as you expect they would. You can use this to kind of further optimize your React components and turn your deck.gl components if you want. We tend to not find this completely necessary, but to give a kind of contrived example, in this case, the parent will actually render every 1 second due to the state update. If the child component was not wrapped in a memo call, then we would actually expect the child to also render anytime the parent does, which would in turn refresh data every 1 second, and then in turn would kind of recalculate the attributes for the deck.gl layer because the data is updating. It's obviously silly code, but what it does illustrate, again, is that we're thinking in React. The way that we use React.memo in traditional React land works the exact same as it does for the custom render. Now some more fun stuff. So React server components, or putting PHP in JavaScript. This is pretty new. It's a new type of component that renders ahead of time before building in an environment separate from your client app or your SSR server. This separate environment is the server in React server components, and they can be ran at build time as well as kind of ad hoc at runtime. In this code example here, there's actually a few really interesting techniques at play. Server components introduce a new way to write components using async and await. So when you await in an async component, React will actually suspend rendering until that promise is resolved. And this works also across the server and client boundaries with streaming support in suspense. So you can even create a promise on the server and then resume it and await it on the client side through that bridge. It's kind of insane, actually. And you can kind of see that here where we have note is a database call that's being awaited. The comments is not being awaited, so that's just a promise. This is an entire React server component. So note is actually being generated on the server, all the HTML on the server. The suspense boundary here is actually kind of bridging between that server and client boundary. And then comments is resuming that promise on the client side because of use client directive. And then once that promise is resolved, it can go through and actually render out those comments. So this is a good technique if you have kind of like prioritized parts of your DOM or parts of your application that you want to render first to users, and then sort of lazily render other kind of asynchronous information below the fold or whatever it end up being. And the really cool aspect for our use case is that we kind of have more empowerment to the composition patterns that I mentioned earlier. So a really common use case that we're seeing here is like data fetching, data transformation, and formatting. You can do all of that work in a React Server component. Again, it's just a hook, so you can use it also in a client context just as easily. So you can get all that information and pass that into an actual deck.gl layer. So as an example of kind of what we're dealing with today is that we might have something like a color value that's set for a layer by the user that's stored in a database. So we'd actually fetch that user's setting from the database. We actually have in this case, it's be like an arrow table that we're grabbing from an API. We can actually inject those two things together and then send all of that information to the client. So all that actually happens on the server. We have the ability to scale things out, and then the client is none the wiser. And again, what's great about this abstraction is that all of that stuff that I just said can actually be used, either in a React Server component or a client component. It's completely shareable because it's just React, right? Another really interesting and fun aspect that's coming up is the React compiler, which kind of gets you for free. So the React compiler is a new experimental build time tool that the React team is creating, and it will actually automatically optimize your React applications. So it works with plain JavaScript, and it kind of understands the rules of React. So you don't need to rewrite any code whatsoever, actually, to use it. And it has day one support for custom renders. So in the future, we're hoping that the React team opens up the ability for more plugins to tie into that compiler system such that we can optimize that even further for targets like deck.gl. But in this case, this is kind of like the before compile example. We have on hover callback that's not wrapped in a use callback in this case, right? Hover data is being assigned to a collection here. So anytime this component renders, those would be sort of new objects in memory. We have an inline anonymous function for a get position function accessor, all that fun stuff. If you run this through the compiler playground, which you can actually check out online, it creates these hieroglyphics here. But the cool thing to note is that that on hover function that we saw earlier there on line 4, that's being automatically memoized. Hover data is automatically getting assigned a shallow compare. You might want to add in more static compares to yourself, but it does that for you. The get position callback that was sort of inline, or it's been hoisted up and it's also been memoized, so you don't actually have to worry about that. So all of that happens for free. That is the output of the compiler. And so while we don't necessarily need to worry about a ton of diffing logic when it comes to deck.gl, because there's already extensive diffing that's done, and it's great, this is just more of a peace of mind, right? And more importantly, as a large team, if you have one, you'll have to think about and pester your engineers to everything in a use callback or wrap everything in a use memo, et cetera. So we've been using the custom deck.gl renderer in a production grade application for a little over a year now. So we feel like the API is pretty strong and it works really well. But there are a few things that we would still love to tackle. Notably, some form of like an HTML component so that we can pop in regular React DOM where we want inside of the actual deck.gl tree and just have it work. So as an example, you could have maybe a bit of almost like a tooltip, but a bit of DOM that's above a piece of data on the map, right? And actually have that projected to that. And again, you're just writing React at that point, so there's nothing special attached to it. We've actually used a similar technique for this in our application where we render the deck.gl tooltip in a full React component and do some tricks to make that happen. But it allows us to have very custom, fully React-powered tooltips, and we don't need to do anything special. Another aspect that might be interesting to play around with is atomic layer updates. So what we mean by this is that given a large list of layers, you may only need to ever update a single one in the tree at any given time. Today, when we're kind of using the reconciler, we're triggering a re-render in deck.gl by the setProps method, and then just passing in that new array of layers. This works fine due to the excellent diffing, as I mentioned, that already occurs in deck.gl. But it would be kind of neat to maybe experiment with invalidating and updating just a single layer versus all of them. So a good example above what we do today shown there. In the future, it might be an update layer call that invalidates just a single layer. I kind of mentioned it earlier, but the reconciler actually has two modes. There is mutation mode and persistence mode. And the atomic layer updates may not be necessary if we trialed the persistence mode in the reconciler. The default behavior is mutation mode, which makes sense for things like the DOM because you're creating these DOM nodes and then you're just modifying them directly afterwards. However, there is the alternative mode, which is used in like React Native, which is called persistence mode. And all instances are recreated each time in that environment. So I guess that ends up being a lot more efficient for host environments such as iOS and Android. And so it might be a better methodology for us in this case as well. And lastly, we've not explicitly tested it out, but we'd love to make sure that the custom renderer, works out of the box with some of the existing community tools. So we could tie it into things like MapLibre and Mapbox and ArcGIS, et cetera, and just have everything sort of work from there. And that's it. Questions at all? Yeah, go ahead.
So I couldn't see your sample code. Does your DOM tree work with TypeScript?
Yes. Yep.
So that's one thing that the current official React package does not work.
Yep.
Because the React imports from the layer packages do not quote unquote return a JSX component.
Yep. So part of the magic of, let me reshare. So part of this extend function, what it actually does is it adds effectively this namespace or this name to the JSX namespace itself. And so you can basically help inform React, hey, this now exists as a valid JSX element. One aspect that we're still trying to get better at as far as type hinting is things like data prop, for instance. You can typically infer that pretty well in these components, but sometimes we do have to kind of augment the, the deck.gl types a smidge to make sure that they can, get that information correctly. So that's baked into the custom renderer that we have. Yeah. By default, as I mentioned there too, all baseline deck.gl layers, even things like the geo layers and such, those are all extended by default. So day one, a developer could just hop in and start writing JSX. It's only if you need to extend custom layers, about that function and use it.
Maybe more a comment, but given the amount of effort you put into this, you must have an application that has quite a bit of React and quite a bit of deck.gl.
Yeah, it's pretty huge. Yeah, unfortunately, I unfortunately cannot show it off because it's Department of Defense work. But yeah, if I can show something, I will. We are actually going to after this conference deploy like a GitHub page that actually shows off a bit more of the kind of React server components and the React compiler stuff that I was talking about earlier. So like a much broader example of a lot of these techniques all at play. Yeah, it's we're up there as far as line numbers go for React and for deck.gl. So great.
The other thing is, obviously you've been engaging with us for quite a while, and you've had a PR open.
Yep.
I think we pointed you to the deck.gl community, possibly as the first good home.
Yep.
What you're going to call it, deck.gl?
Yeah, I'm not sure on the name quite yet either, but yeah, I was telling a few folks earlier, right before this talk, I actually upgraded everything naively to the latest React version of 19 that has the React server components and React compiler. And they actually had broken some things. And so we'd have to do a few passes just to make sure everything's working before we contribute it back to the deck.gl community repo.
Is there anything you need from us too?
So I guess from the actual deck.gl team to be, are we doing things correctly in that reconciler portion that I was showing off earlier? So notably in here where we're injecting things into these commands, making sure that we're just using the appropriate, methods on the deck.gl instance.
I'm not sure we're React reconciler fiends.
Well, so you don't actually necessarily need to know what these do per se. They are typically, quite descriptive, but That'd be sort of a collaboration that, we would have of as far as like, hey, this is what, this is when this occurs. What should we do from a deck.gl perspective? We also wanted to kind of do really fancy things like automatically, filter layers based on which view they're attached to from a parent-child perspective. And again, because there's no restrictions on direct children like that, so just really we're accommodating use cases like that would be neat.
Sometimes this year we'll see this as a.
Yeah, I think so. Yeah, our team is gearing up to actually do a few more open source contributions here very shortly. So we're hoping to reignite this fire, but it's at least been battle tested for quite some time now.
I'm mostly curious about seeing an example app or something.
Oh yeah.
I imagine the full one can't.
Yeah, can't do the full one. Yeah, if you guys want, I can show you off what I have on my system now for that demo. It's a little bit incomplete because I didn't get to finish it out, but thanks jet lag. Yeah, I can kind of talk through some of the techniques and stuff. But we're really excited, about things like the React Server components too, just because it does have a lot of play into some of the data discussions that we were having today, where we have a problem right now where not all the data that is sent to us from data providers has the information that we need. So we actually have to recalculate or calculate things like colors and size and things like that purely client side because they are typically driven by user settings, right? And wouldn't it be cool to inject that all server side and just get sent a nice lovely, arrow table with everything included on it for us? So.
How hard would it be to port like an existing deck application that's using our React syntax to this? Doesn't look the same.
Yeah, it's pretty simple using the current React package. I would say the biggest gap probably is the base map support that has, but otherwise it's effectively almost the exact same. So there's pretty much feature parity. You get actually more features with this one.
Yeah, but is it possible to just like take the code and just replace the renderer and it works, or do we have to
pretty much actually
as JSX?
So that's optional. So as a iterative step, you could, if you're getting a collection of layers that you're instantiating and then just passing that as a prop to the deck.gl component, you could keep doing that with this one as well. Or you could convert those into more inline JSX components, be freely up to the team. And you can actually mix and match as well.
So like, are you saying the layers prop is an array, right? You're saying instead of doing like new text layer, you can just use this JSX syntax in that layers array and
we actually have not tested that. That's maybe possible, but no, it would be like you can define both that layers array at the top level and also have JSX, and it would just sort of it'd be an addition to that initial collection. Let's see.
But maybe more than you're saying, it's like take that layers variable and then make it like the child of the render instead of passing it into.
Yeah, you can.
How's your experience been with debugging? Does it make it easier, harder?
I would say it tends to be easier. Like debugging the deck.gl side is really no different, in our experience at least. And the thing that makes it a bit easier for us at least is that the way that React works, you're kind of getting exactly what you're expecting at any given time. So, if you have a use effect, for instance, that doesn't have a dependency array in the second argument or something of a nature, you might get a recursive loop. You can kind of expect that if you've worked with React for any given amount of time. And it's sort of the same concept for interacting with deck.gl things. But really, it's more of just syntactic sugar more than anything. It just has very nice interop with React things. So it's really not that far from just going with deck.gl directly, actually.
Okay.
So the only aspect that might be interesting to do more debugging is things that happen in here, basically.
Yeah, I mean, it looks interesting, but I think it says then to most of us, that's just like.
I mean, to me, it's also like, but
it's like a nice set of functions. I don't know.
Purposely obscure, I think, for consumers, but.